Hey, what's up, guys? Welcome back to my channel and glad to see all of you guys here tonight. So today we are going to discuss the three types of iso contours in thermodynamics. So if the temperature is a constant, that process is isothermal process. And if the specific volume is a constant, then we call it as an isochoric process. And if the process has a constant pressure, then we call it as an isobaric process. So let's take a look. So for example, for thermal EOS, if the function is P little v equals to RT equals to 0 for an ideal gas law, then turns out to be the contour will be looking like this. So x-axis is a specific volume, y-axis is pressure in kilopascal, and z-axis is in temperature. So if we look at the lines like this, so as we said, the z-axis is temperature. So all the lines along this, they are all constant temperature. And a similar thing, all lines along these lines, then the specific volume does not change. Then we call it as constant specific volume. Then those are the three iso contour. So if the pressure does not change, we call it as isotherm. If the specific volume does not change, we call it as isochoric. If the pressure is a constant, then we call it as isobaric. All right, then let's look at an example. So this is an isothermal process with ideal gas law. So it says a piston cylinder device contains 0.6 kilogram of argon undergoes an isothermal transformation in which the volume is doubled. So in order to determine a thermal EOS, we have to know the substance and the phase. So the substance is argon, then we can assume it's a gas phase. However, if your substance is in H2O or in refrigerant, which is R134A, then you would have to determine the phase first. So anyway, our thermal EOS, the substance is argon, and the phase is in gas phase, so we can apply ideal gas law. Also, for the whole process, initially, argon has a pressure of 550 kPa and a specific volume of 0.08333 meter cube per kilogram. And says assume argon is an ideal gas, and asks for the initial temperature and the final temperature, as well as the final pressure. So let's take a look. So the first one is asking for the initial temperature. Then with ideal gas law, we know the initial pressure and the specific volume. And by looking at the table, we can find the R value for argon. Then turns out to be the initial temperature is 220 K. And since the process is an isothermal process, so the temperature does not change. So the final temperature equals to the initial temperature, which is still 220 K. And the third one is asking for final pressure. So we could think about ideal gas law, PD equals to RT. Then we know the final temperature. Then we probably need to know the final specific volume. So the problem says for the process, the volume is doubled. Then volume is specific volume times mass. So the mass does not change. So if the volume is doubled, means the specific volume is going to be doubled as well. So it turns out to be our specific volume is this number, and you can plug it in, and it turns out to be the final pressure is 275 kPa. So this is our three iso contour. Did you get it? All right. This is all we have for today's part. Thanks for watching. We'll see you next time. Bye.